Today, we are working on LeetCode problem 513. Find bottom left tree value. Now, this problem is actually not that difficult, but it is really tricky. And if you're not careful, you might just get stumped. Like and subscribe. As usual, we start by reading the problem. Given the root of a binary tree, return the leftmost value in the last row of the tree. Very simple problem description. In example 1, the bottom left tree value is pretty straightforward. It's this guy right here. It's on the last row and it's the leftmost node on the last row. In example 2, things are not so straightforward. You might think that the bottom left tree value refers to this node, when actually, well, it's not, because the problem description wants us to find the leftmost node on the bottommost row. Note that it is the node on the bottommost row, which means it's the furthest distance from the root, and it's the leftmost node in this row. When I first saw this problem, I thought, oh, that's pretty easy. All I have to do is to keep going left, right? Well, not quite. If you keep going left all the time, you're going to end up in this node over here, which is not correct. Sometimes you need to go right in order to access the bottommost row, and then you have to go left to find the leftmost node in the bottommost row. The trick, therefore, is to keep track of not just 1. What your bottom left value is, and 2. How deep down the tree it is. Finally, for each node, its bottom left value is the deeper of the bottom left values of its two children. And if they are the same depth, then you prefer the left node. Let's look at how it looks like in practice. For this node over here, this number 4, it is a child, so its leftmost value is itself, and its depth is 1, 2, 3. Similarly, we will fill in the numbers for all the other leaf nodes. The number 2 node here is not a leaf, and it only has one child. So its bottom left value must be the same as its child. This is also the case for the number 5 node. The number 6 node here has 2 children. Since they have the same depth, we favor the left node. The same logic applies to this number 3 node. It has 2 children, one who has a bottom left value of 7 at depth 4, and the other has a bottom left value of 8 at depth 4. Since the depth is the same, we're going to favor the left node. Finally, we get to the root node. The root node has 2 children with different bottom left values, but their depth are different. In this case, we're going to take the one which is at a deeper level. And once we've reached the root, we can now return the answer, which is this one right here. Finally, let's turn this all into code. We start by defining a helper function. The helper function will find not just the bottom left of a node, but also the depth at which this bottom left is found. We need to pass in an additional depth argument to keep track of how far down our current node is. There are 3 cases that we need to take care of. First, if the node is a leaf. In this case, its bottom left would have to be itself. The second case is when the node only has one child. In this case, the node's bottom left must be the bottom left of its only child. In this case, we get the bottom left of both children. And return the one which is at a greater depth. If they are equal, then we return the left one. Now all that remains is to call the helper function from our main function. And there's our solution. I hope that video was helpful to you. And if you enjoy my content, remember to throw me a like and subscribe. It helps out small content developers like myself so much. Thanks for coding along with me. This is Alex does LeetCode.